In this video, we're going to talk about solving quadratics by taking roots. You can take notes in your packet on page 2. Our first question here is, how do I know when I can solve by taking roots? And what our notes mean by taking roots is by taking a square root of both sides to solve an equation. If we have a problem in standard form, which is ax squared plus bx plus c equals 0, where our middle term, bx, is missing, we would just have an x squared term, and so in order to solve algebraically, we would isolate this x squared and then solve for x by taking the square root of both sides. The other type of form where we can solve by taking the root is in vertex form, which is a quantity x minus h squared plus k equals 0. And this is where h and k are the vertex of my parabola, which is the maximum or minimum when graphed. So how do I solve by taking roots? The example here, we have one variable that has an exponent tacked onto it, and we're going to have to solve algebraically. And if you remember, we're going to work from the outside in to get to our x and isolate it. So our first step in this is subtracting 2 from both sides. And then dividing by 3. And then to get rid of the exponent, we take the square root of both sides. Now when we take the square root of both sides in solving equations algebraically, we have a plus minus tacked on to whatever the square root of that number is. This is because positive 3 squared will give us 9, and negative 3 squared will also give us 9. So that's why it's important to make sure you have that plus minus symbol. And then solving from here, we add 7 to both sides. But because we have a plus minus 3, we have x is equal to 7 plus 3, and x is equal to 7 minus 3. And so then we have two solutions to our equation, x equals 10, and x equals 4. So what happens if there's a negative under our square root? That's where we have to introduce a new number, I, which stands for an imaginary number. I is equal to the square root of negative 1, and the reason this is important is when we have a negative under a radical, we can simplify it by pulling out an I, which just represents the square root of negative 1. So in this example, once again, I'm isolating my x by solving algebraically, so I'm going to add 6 on both sides, and then divide by 7. And then in order to solve for x, I take the square root of both sides, which then leaves me with the plus or minus square root of negative 19. Well, negative 19 can be rewritten as negative 1 times a positive 19. And from what we just learned about our new number I, we can simplify this to say plus or minus I times the square root of negative 19. And the reason we do this is to write what's called a complex number. And a complex number is not real or imaginary, but rather has parts of both. If you notice here, this number can be written as 0 plus or minus I times the square root of 19, where I is my imaginary number and 0 is my real number, which makes this number complex. We use complex numbers and imaginary numbers when solving quadratics.